The following scenario is typical of the automotive industry, but could easily be translated to any manufacturing industry. Powerway is software, delivered as a service that provides visibility to process requirements and performance, so you can see and control risk. In this example, Powerway and its partners, Intel, Microsoft, and Dassault, illustrate how service-oriented architecture, SOA, allows for real-time exchange of mission-critical information. This rapid and collaborative exchange collapses the time and reduces the cost of addressing pre-launch dilemmas as they arise. In this scenario, a supplier brake assembly is not stopping the vehicle in the required distance. The supplier has gone into Powerway.com and changed the functional test's value to indicate this failure. While in Powerway.com, the supplier acts proactively and sends an email to the OEM, copying the release engineer and the supplier quality manager of this issue. The supplier submitted 2 proposed changes to help solve this issue. 1. Add 35 millimeters to the rotor diameter. 2. Change the material to improve the energy attenuation characteristics. Also compounding the problem here is that the tooling supplier has a closing window of opportunity in order to change the tooling for this brake assembly. Once saved, its status now shows up in Powerway.com as red. Meanwhile, the platform manager is doing her daily dashboard reviews and noticed that the brakes are red where yesterday they were green. She immediately knows that there's an issue. She scrolls down to look at the rest of the dashboard to see if anything else has changed, then launches the program status to get more information, which pops up in Microsoft Excel and is linked to the data on Powerway.com. Again, she sees that the brake is highlighted in red and disapproved. She selects the brake, which imports a 3D XML image. Clicking on the image allows the image to be rotated to gain a better view of the brake assembly, with the red part in it. In this case, the brake rotor. To gain more information on why, she immediately goes to the messaging system built into Excel to start an instant collaboration session with the supplier quality manager. Once the instant messenger screen pops up, she writes, "Hey, are you there? I need to discuss this problem with you." The supplier quality manager replies, "Well, yes I am. What's the issue?" She indicates that her dashboard shows the brake assembly has been disapproved by the supplier, but the pilot build is in 3 weeks and wants to know what the problem could be. The supplier quality engineer indicates that he'll start a collaborative session with the data in Powerway.com and asks her to launch a live meeting session and switch control over to him so that he can display what's on his desktop. Once he has control, he sees the issue created with the brake, and he drills down to see what the issue is. He indicates that there's not enough energy being attenuated during braking, so the vehicle is not stopping in the required amount of distance at 60 miles per hour. He notices the recommendation of the supplier and notes that the size of the rotor can either be increased by 25 millimeters or the rotor material can be completely changed. The release engineer is currently working on a digital mock-up review, but is still able to receive the request because he's online. He immediately responds by saying he's been working on a digital mock-up and hasn't seen any alerts. The supplier quality engineer explains what has happened, and the release engineer requests control so he can get to the heart of the problem. Once in control of the session, he searches for the specific vehicle program, drills down through the product structure until he gets to the chassis area, and then goes through the chassis so he can isolate just the braking assembly. He then brings up the braking assembly into the session. He verifies that he has the correct part, and then he goes in and makes the requisite change by adding 35 millimeters to the diameter of the rotor. Once the change takes effect, all the associated parts are modified as well. He next performs a clash analysis to see if there's any clash interference created by this larger part. While he's doing this, the supplier quality engineer and the platform manager are watching this in real time and seeing the results of the clash analysis. They can all see that there are multiple clashes with a variety of different components and that changing the rotor diameter is not an option. He then types back, "There's not enough room here." There are clashes taking place with a variety of things, including the wheel and the steering. We're going to have to go with a material change. The platform manager's response reiterates that the pilot is just 3 weeks away and is dismayed that they are just now finding out about the problem. The supplier quality engineer requests control of the session in order to use Powerway.com to better understand what's in the DFEMA and to find out what it has to say about this. The supplier quality engineer drills down on this part and brings up a 3D XML image to make sure he has the right part. The rotor is highlighted in red automatically by the status in Powerway.com. He then clicks on the DFEMA link and launches a document that shows what's in the DFEMA. Here he verifies that he needs to match the rotor size to the gross vehicle weight in order to stop it in the right distance. The vehicle requirement is 1,400 to 1,650 kilograms, and it indicates that the vehicle weight has just crept over that limit. The platform manager realizes that there's no choice at this point, that they need to move forward with a material change. She asks the managing engineer to provide an emergency authorization to the supplier to kick off a tooling change. She also requests the release engineer to create an engineering change request and get it into the supplier right away. Everyone agrees and leaves the instant collaboration session. The release engineer then goes in through Innovia and gathers the data that is necessary through Innovia and through Powerway.com for this engineering change request. It automatically creates this engineering change request via some links within Innovia and creates a Microsoft Word Smart document with embedded 3D XML files and data pulled from Innovia and Powerway.com. The 3D XMLs are of a full assembly and an exploded view of the assembly. The release engineer goes into the exploded view and brings up the product structure and turns off the visibility of the parts that are not critical. By hiding those that are green, anyone viewing this document will only view the parts that are critical. When he's done making that change, he then positions the 3D XML image so that it's better viewable on the screen. Then in real time, with data from Powerway.com, he's able to use the task pane on the right to generate the smart document. He enters a description of the issue, changes the part status to release, the priority to high, and identifies the change reason and a number of other items. As he's doing this, the document is auto-populating. He changes the plan date, and the actual end date says it's in work. And once he's completed the change request, he will save it and send it off via an engineering change process workflow through Innovian. While the process was truncated for this presentation, you can see that process of getting products to market can be streamlined through the use of technology brought together by Powerway.com.